Okay. So, your homework assignment was to get a Hello World program working, right? Okay, so we'll look at that here shortly. And then you were also to write a paper. The paper, what was the topic of the paper?
Java.
Java versus?
C# and ObjectiveC.
Okay, and what were you supposed to compare it on?
Advantages, disadvantages, and career path.
Okay, so what did we find out? So you were looking at Java versus C# versus Objective-C. What did we come up with? What were some of the interesting highlights that you found?
Platform.
Who?
A platform.
Platform independence for Java?
Yes.
Okay.
Everything we.
So that's an
discussed in
advantage of
class.
Java.
Yes.
Okay.
Everything we discussed in class.
Okay. All the rest of the crap we discussed in class. What about Objective-C though? The curveball here was Objective-C. Throw that in there.
Disadvantage of Java is slow to execute because it works on GVM.
Okay. Virtual machine, so it's slow,
Yes.
relatively speaking. All right. What about the pros of C#? What's good about C#?
Use C++ syntax, like syntax.
And Java.
And the performance is high. I mean, like the advantage for performance. It's not like slow or fast.
Okay, so you get the simplicity of well, maybe not simplicity, the common syntax from C++ that Java also had without the slowness. Okay, but you had to be on a specific platform. You had to be on Windows.
Yeah.
Okay.
Definitely.
Any other benefits of C#, independent of what we had talked about?
.NET.
Well, that's the running on Microsoft thing. Well, why is .NET a benefit in general?
I'm not sure if it's benefit or not, but it's platform independent.
As long as it's running on .NET, which is basically saying it only runs on Windows.
Right.
That's saying the same thing. But does C# have any other advantages over Java besides speed?
IDE.
Okay, tell me what about that?
It has it's a huge tools of IDE.
Okay, so you got Visual Studio. Is that what you're talking about? Integrated
Yes,
development
yes.
environment? Okay, so C# programming is done in a tool called Visual Studio. Java is done, there's several different IDEs for Java. The popular ones, the most popular is probably Eclipse, which I use in here. NetBeans is another one. Huh?
I'm using command format for that.
Yeah.
For Java too.
I mean, I think it's maybe fair to say that Visual Studio is a more robust development environment than Eclipse. I think that's fair. I think Eclipse is pretty good, but I think Visual Studio, it's been through the paces, it's been around for a long time, and they are solving a problem on only one platform. So it's almost the same thing as the language comparison. Eclipse, you can download Eclipse for Mac, you can download Eclipse for Windows, you can download Eclipse for Linux. Well, they had to write that program 3 separate times. The program's written in Java, but, so chances are they were able to at least port it pretty easily without having to rewrite the whole thing. But there may have been aspects of it that were too slow initially, which is why they had to do it, which might lead us to believe that Eclipse might be a little bit weak compared to Visual Studio, which has been written a long time ago, and they've released updates several different times, blah, blah, blah. Okay, what else?
About the Java, actually, the advantage, you can use it for internet and business, internet application and business. About the C# or Objective-C is just for mobiles. No, actually, Objective-C is just for cell phone, you know, it's for iPhones, stuff like that.
Okay, so you think Objective-C is just cell phone, iPhone,
Yeah.
mobile development?
Yeah.
All right, well, so here's the Macintosh App Store.
And for Mac.
Mac.
Yeah.
Yeah, so not just mobile.
Yeah.
Yeah, every single app that's on here was
Just
written in
for-
Objective-C.
I mean, just for Mac.
Yeah, Mac, that's it. Yeah,
It's
so
kind of like disadvantage for Objective-C.
Yep. So disadvantage of Objective-C is you're doing Mac-only development.
Exactly.
Okay, I'm fine with that.
And C# cannot work in mobile phone, you know. It's just for like PC. I mean, there is like.
You can do mobile application development with C# for Windows 8. Windows 8 Mobile
Okay.
is a .NET platform.
They're using C#, they're using C.
Hmm. Nope. Anything .NET. You can write Windows 8 mobile applications using any of the .NET languages. You can use a dumb language like Visual Basic.
It's not kind of like fabulous for this in.
Say this again.
It's not like fabulous to use this in the mobile for that.
You mean popular for
Yeah.
using C?
Yeah, C#.
I would say C# is most popular for writing Windows mobile applications.
Okay.
So if you're writing mobile applications for Windows phones, you would very, very likely be writing it in C#. But you can write it technically in any of the .NET languages because it's a .NET platform, Windows Mobile. So we might say that Objective-C is Apple product only. You might say C# is Microsoft product only. And you might say Java is everybody product only. KK, thanks. Okay, so that might be the benefit of Java. Java's shining benefit is the fact that you can write it for any platform. And that's the whole reason why we picked Java as our development language in education. Java is not better or worse than C# from a teaching perspective. They're the same language. From a teaching perspective, they're literally the same language. I'll kind of give you a little a show today. I'll show you. We'll write our Hello World program in Java. Then I'll show you what we would need to change to make it work in C#. It's like 2 things. And I don't mean, not even full things, like change capitalizations and stuff. It's not much. They're basically the same language. But the advantage we have in Java is I don't have to worry about what kind of laptops you guys have or what kind of desktops you have at home. I know that you can do your homework for this class. Because you can get Eclipse for whatever platform you have. Whether you're a Mac or Windows or Unix, doesn't matter. Eclipse runs on it. But
If someone knows any one of the programming language, it's how long it takes to learn the other one. I mean, if you ask about little things to change.
okay, so that's a good question. So you want to know if you already know one programming language, how long would it take to learn another programming language? Let me just make sure this thing's still cooking. Okay. Well, I guess the short answer is depends. I'm a big advocate that programming is programming, and once you understand how to program, learning another language should come very, very quickly because all you're learning is syntax. You're not learning how to program. When you're a beginning programmer, you're learning how to program and you're learning syntax. So you're fighting 2 battles at the same time. And once you know how to program, now it's like, oh, well, to solve this problem, I would do this, this, and this. How do I accomplish that in this other language? Something like that. So now, if you already know Java, switching over to C# should be very, very quick because they're very similar languages. If you know Java or C# and you have to switch over to Objective-C, it's going to be a little bit more of a learning curve because they're still based off the core root language C, but visually they look different. Objective-C is going to be a little bit more intimidating initially. But once you get over that initial learning curve, it's all the same crap. It's just like natural languages. When you look at a language that you don't speak, it looks like gibberish to you. Once you learn that language, you're like, okay, that's not gibberish. I have a student in one of my undergraduate classes, and I may even referenced it last time. I think he's writing in Arabic. Every single class he writes on his papers, he always writes this little line at the top. And to me, it just looks like squigglies. That's what it looks like to me, because I don't understand the language. It looks like a 4-year-old squiggled on the paper. I mean, you know what I'm saying, right? I mean, that's what it appears like to me.
Signature.
Yeah. So, not understanding the language, it does. I mean, I'm sure what he's saying is something that I could easily say in English. Yeah. But I don't understand the language. So there's that initial learning curve.
What if he cussing you out in Arabic?
That's cool. I'd give him extra credit for that. Go ahead.
About about the Java? Can I consider it's kind of like disadvantage of Java because I think Java cannot run on iPhone.
Java does not run on the iPhone. Let me think if that's true or not. It's mostly true at least, but there's no reason why Java couldn't run on the iPhone if they made a Java virtual machine. They just don't have a Java virtual machine. I mean, you could argue that's a disadvantage, but I might ask, what would you use Java for on an iPhone?
I mean, no, I want to make sure this disadvantage come from Java or come from iPhone.
You mean the fact that Java doesn't run on the iPhone?
You know what? Yeah.
The reason whose fault that would be Sun Microsystems for not writing a Java virtual machine for iPhone. Now, it could also be Apple's fault for not giving them the open architecture to write the virtual machine on the iPhone. So it might have been both of their faults. Where
That means I can run C++ in iPhone.
It's only for .NET.
And C2.
Well, iPhone only understands Objective-C. When you write applications for it. You can actually, there are some C++ libraries, so you could do some C++ on iPhone, but it doesn't run it natively.
Like iPhone use JavaScript if you use the Safari. So
JavaScript and Java, two different things. They're not even loosely related, just except for the word Java. They're not the same thing. But yeah, Safari understands JavaScript, but that's different than Java. The Java programming language and JavaScript are not even made by the same people. They just happen to share that first name.
Yeah, because Microsoft made JavaScript, didn't it?
Microsoft made VBA, not VBA. Well, I do make VBA, but that's not what I'm talking about.
It was by Oracle. No.
What's
they
the scripting language? ASP. Microsoft made ASP, and before ASP, there was VBScript.
Okay.
So you had VBScript. And so in the early days, it was VBScript versus JavaScript was the scripting language war for web browsers. Then JavaScript won that, and Microsoft kind of took their VBScript concept and turned it into ASP, which is actually a different technology. But then ASP became ASP.NET and that kind of crap.
Okay, that's mean you mentioned about last week about we cannot install like Mac in Windows.
Correct.
Yeah.
You can't install the Mac operating system
Yeah.
on a PC. You can't put it on a Dell or something like that.
Because the hardware, the process.
It's actually because of Apple. Apple, when they write their operating system, they write Mavericks or Mountain Lion, it specifically looks for a very specific type of firmware called EFI.
Okay.
Most old PCs, or well, most PCs don't use EFI firmware. They use something called the BIOS.
Okay.
And BIOS is a much older technology. Apple specifically looks for EFI. I think they might even look for an EFI signature that's specifically from Apple. They can do that because they control the hardware and the software. So they can look for their own hardware and say, only run if I see my own hardware. Where Windows can't put those protections in there because Microsoft writes the software for a zillion different computers, including Macs.
Because it is kind of like Mac, they like create something it's kind of like compatible with the Anthem.
Say that one more time.
I mean Mac, when they create the operating system, the Apple, doing something compatible with the Anthem, the chips.
Yeah.
Exactly.
But they're the same processors.
Okay.
I mean, so this has an Intel processor. This has an Intel i7 chip in it. Same kind of chip that would be in a new Dell laptop. There's no hardware difference anymore.
Okay.
They're all running the same crap
The
inside.
problem is coming from the BIOS. I can see that.
The problem it's not from the BIOS. It's that Apple can specifically look for the signature of their own hardware. They only write software to run on their own hardware, so they can specifically tell their software to look for their own hardware. And if you don't find Apple hardware, don't install. Microsoft doesn't have that luxury because they're not writing software for their own hardware. They're writing software for everybody's hardware. Dell's and Hewlett-Packard's and all these other things. So Apple has the advantage from a proprietary sense there because they They only intend for their software to run on their own hardware. So they can just look for it. They can have their EFI or BIOS or whatever. They can have it just say, yes, I'm Apple hardware. You can trust me. And if it doesn't give them that message, don't install.
That means in another, opposite for that, can I like install on system Windows in the Mac?
Yeah, no problem.
I can do this.
Oh yeah, you can install Windows 7 natively on a Mac. So you can literally go out and buy a brand new Mac, and you can put Windows 7 on it and not even run the Mac operating system.
This is kind of advantage for Microsoft.
Huh?
This is kind of advantage for Microsoft.
Advantage. Okay, an advantage for Microsoft in that now there's more machines in the world that can run their software. Yeah, I mean, a Mac can run both Windows and the Mac operating system and Linux if you want. So what I tell people in technology positions, especially like in IT industry, the correct laptop to get if you're an IT professional would be a Mac. Not because Macs are necessarily better. It's that you have to be able to deal with all sorts of different technologies. And a Mac is in one machine is 2 machines or even 3 machines if you want to run Linux on there as well. So for 1.7 times the price, you can get 2 machines is the punchline. So when you look at it through that lens, Macs aren't as overpriced as people think. But if you're grandpa who's just going to use it to check his email, well, now a Mac isn't the right tool for the job. Get him an iPad or get him a $300 Hewlett-Packard laptop and replace it every 2 years. Because that laptop will let him check his email just as well as the Mac will. So for technology people, the Mac computers are very good purchases because it's one machine you have to carry around that will allow you to do all your crap. So other than that, for a normal person, if you're not a technology expert, a Mac is just like it's like a Cadillac versus a Chevy for cars. They both get you to work. You could check your email on a Mac, you could check your email on a Hewlett-Packard laptop. One of them is going to cost you $1,500, one's going to cost you $500. So decide, do you want to pay for the flashy Cadillac, or are you cool getting to work in a Chevy? Depends on the person, right? So that's the punchline with Macs, I think. But when you have somebody who comes up and tells you, oh, Macs are just better, it's a very ignorant statement. You have to qualify. Anytime you're comparing different things, like we're doing right here, we're comparing programming languages. You really have to qualify it. There isn't a clear answer. I mean, can you say that Apple makes better hardware and think, fine. So these laptops, he's got a 13-inch MacBook Air, I have an 11.6-inch MacBook Air. These are really nice design laptops. They're super light and all this stuff. You got a Mac there, right?
Yes.
Yep. So that's a 13-inch Air. But I see some other laptops out there. So we have the pink Mac back there. This is more of a netbook size device, but I'm guessing that probably has a little bit higher power processor. It's one of the larger netbooks. Okay, so your machine probably cost half of what his machine cost, but maybe for what you use it for, that's the better device for you. Everything's a qualifier. There isn't a clear answer. Apple's not just better. Even with iPads. iPad has 95% of the tablet market. Significantly more of the tablet market than it has of the smartphone market. Is the iPad better than Android tablets? Well, I think you can generally say yes, but it depends. In enterprise, the better tool might be one of the Windows 8 Surface tablets. It might integrate with the stuff that's going on at your business much better than an iPad might. So everything's a depends. Get the right tool for the job, not just the tool that looks the best on paper. Apple's rarely look the best on paper because of the price. But sometimes, especially for technology experts, the Mac makes the most sense because it's the one machine you can do everything on, even if you spend 90% of your time in Windows. That 10% of the time you need the Mac on there, you could boot into it if you want to. You can't do that on a Dell. Make sense? Go ahead.
Okay. Another thing about Java.
Mm-hmm.
As you said, you had a good experience with the Java since 2000, as you said.
Yep.
Okay. And we are looking for your advice. It's a good idea to keep, ourselves deeply and looking deeply for the Java programming and get a lot of certificates from Oracle and find like a job who give us like opportunity, for about Java developer.
Okay. So, well, let me put it this way. So you're asking, would it be my advice to focus on Java?
Exactly.
Okay, so this goes back to a comment I said a little bit ago where programming is programming. Once you know Java, you know C#. You can, and I'll prove it to you in a moment. Java and C# are literally the same language. There is so little difference between the two languages that you could take a working Java program, compile it in a C# compiler, and not get nearly as many errors as you would expect. You would only have to fix a handful of things. So I would say from a, depending on what field you want to go into, you would likely be better off for job opportunities to know Java and or C# over Objective-C. Objective-C would be kind of the new cool language, if you will, because Apple's the kind of the rock star with the iPhone and the iPad apps, and now they have the Mac App Store. So that's the language you would do anything Apple related on. But that's a significantly smaller market segment than those other languages will buy you. So even if we say, okay, well, iPads are really, really cool and iPhone has a big market share, fine. But Java will cover you on the Android side of things. Android programming is done using Java. So I don't think there's ever a great argument for saying there's more jobs available on Objective-C than there is for Java and C#. I think you'll always have more jobs available over on that side, the Java and C# side. So the only reason I would focus on Objective-C is if you're interested in writing Macintosh stuff. But the jobs in bulk will be over in the Java and C# side, and it doesn't matter which of those languages you know. They're the same language.
Because my question is coming because the reports when you asked us about it, the career path, the Java.
Mm-hmm.
And most of companies, when I looked, they ask for experience.
Mm-hmm.
7 years, 8 years, I think.
Sure.
And some of them, they are looking for the certification that Oracle provided to is interested to get it.
Yep.
You know what I mean? That means you should pick one of them, one of the roles you are looking for, one of the language.
Depends how important a certification is to them. I would say certifications, generally speaking, are a dime a dozen. I think most places don't necessarily care about certifications. The person who likely wrote up the job description likely has a lot of certifications and maybe doesn't have a lot of degrees, and they put a heavier weight on certifications. I'm speculating, but I think that's fairly common. I've been in a lot of software shops where your top guys, they don't have college degrees or anything, but they have, 50 other letters after their name, most of which took 20 minutes to sign up on online, and they answered a 5-second quiz to get it. And maybe 20% of them were just made up letters. If you just change your email signature, just include a whole bunch of made up certifications after it, do you think anybody would ever question you? No. So, obviously I'm making a big generality there, but I think in the big scheme of things, only certain certifications are really respected in industry, and I can't think of one in the programming side of things. I think most of them are going to deal with more networking side of things. Some different networking certifications or Oracle certifications, database management stuff. So there's maybe 2 or 3 really well-respected certifications that people know in the industry that if you have one of those, you've been through hell. And we probably should pay you a little bit more, that type of thing. But a lot of these, for instance, a good example would be the A+ certification. A+ certification, somebody can get in an afternoon. You pay your money, you take your test, you have your A+ certification. It's not nobody cares about it, is the point. So I wouldn't put very much merit in certifications, but different people have different opinions. If you ask 10 people about certifications, you'll find 5 of them that say they're great. 5 of them would say they're not. There's nothing wrong with certifications, but they don't replace degrees. That's my feeling. So if you come in with a master's degree and you have 10 certifications, I think you look pretty good. If you come in with a high school diploma and you have 10 certifications, I wouldn't give you the time of day.
Good point. Thank you.
Okay. So other questions? Any of the language comparison stuff? So punchline here is there isn't really a right answer as to which of these languages is the best. Each one of them kind of has their pros and cons. Each one of them lets you do some different things. Java lets you write software for any platform, specifically lets you do Android stuff. C# lets you write software for the Windows platform. Also, you can write Windows Mobile 8 stuff. ObjectiveC lets you write software for anything Apple makes, including iPhone and iPad. So, all depends on where you see yourself doing your development. Okay. So, the other part of your assignment was to create a Hello World program, right? In Eclipse. So everybody downloaded Eclipse. This is what Eclipse looks like. Came in here, we'll right click. We're going to create a new Java project. We'll name this guy Hello World. Okay, and it gives us this folder structure like this. So this JRE, this is the Java runtime environment. It comes with all your packages. Don't worry about it. It's just there. This will ultimately run your program. So the source folder, this is where all our source code goes. So we're going to right click on source, click new class. And we're going to call this guy hello.
Why did you get that message at the top?
Oh, the use of the, okay. So inside here we have, I can actually show you out at this one. No, I'll show you in here. Every Java source code is organized into something called packages. It's a directory structure for stuff. Until you write much more complex Java programs, you likely are just going to use the default package, even though it's saying it's discouraging you to do so. Once you write much more complex things, you might want to start organizing your code into different folders, therefore having different packages within there. So you'll see once we create this guy, it's asking us what package do we want to call this. We can call it whatever we want, but the default is just default. And 99% of the programs you'll ever write will probably be this, unless you become a big project Java developer. You're writing large APIs for something or something like this. So we're going to name this guy hello. Click finish. So now you see we have this thing called default package. Had we named that something different, it would have been something different there. Okay, we could have called it CSC535 or something like that. Didn't matter. And now we have one file in here called hello.java. All right, so all Java programs are contained within something called a class. Forget about this public thing for a minute. We're going to talk about this for a little bit. All right, so forget about public. But all Java programs are inside something called a class. Notice it's purple, that means it's important. Okay? Built in. Class is a reserved word in this language. The name of this particular class is hello. All classes have an opening curly brace and a closing curly brace. This is end of class, begin of class. So when I do slash slash like this, that's a single line comment. So everything following the two front slashes is ignored by the compiler. It's for human eyes only. Okay? So this is the beginning of the class, this is the end of the class. Inside of classes are what we use to represent something called objects. So let's kind of fill out some stuff here. Remember, we're dealing with an object-oriented programming language here. So inside of objects, objects are represented as a class. Classes contain class members, where a class member is our fields, constructors, and methods. Those are the three dudes that can live inside of a class. We don't know what they are yet, but those are what can live inside of that opening and closing curly brace. Make sense? Okay. Well, initially we're going to look at methods. Specifically, we're going to look at a very, very specific method. And let me get rid of these comments here, just because they're going to bug me. So inside of our class, inside the opening and closing curly brace of our class, we created something called a method. So let's quickly define methods. Method. Reusable chunk of code. That's what a method is.
So Webster-like.
Methods are a reusable chunk of code. So we can give, so all methods have a name, a return type, specifically in strongly typed languages, and a parameter list. Parameter list represents inputs. So the generalistic syntax for a method would be return type, method name, open parenthesis, comma delimited parameters, close parenthesis, opening curly brace, body, closing curly brace. So this would be the generalistic syntax for a method. Now we're not actually going to write our own methods yet. Who knows, with a 4-hour class we might get to them by the end of today, but realistically, we're not writing methods yet. But in order to even start writing a Java program, we need to understand one method, and that's main.
I thought you said me.
So, the main method. All programs begin and end with main. This is true for C, for C++, for Pascal, for Java, for C#, for ObjectiveC. Well, it's true for VB. Actually, it's true at some level for just about every programming language. It runs on its own. So main is a very, very, very important method. Each language might have its own little twist on what main looks like, but most of them mean the same thing. Okay? So, we can generalistically say that any program, here let's do it this way, any class that we intend to run as our program must have a main method. And just so happens, right now we're writing pretty easy Java programs, so all they have is a main method. So these first two words, don't worry about those right now. Unimportant.
Question. When you said they start in with main, do you mean the brackets or?
Yeah.
Okay.
So start here,
Okay.
end here. So your program, when you run your program, it will go to the first line of main and start trucking.
Got
And as soon as it gets to the end of main, your program has ended. All the different directions it might turn in between those two curly braces might keep you going for a while. But generally speaking, you begin at the beginning of main, you end when you hit the end of main. Okay, so for right now, we're going to pretend like public and static are magical words that just need to be there. We'll talk about them in more detail later on. But for right now, they have to be there. So forget that you even see them. Now to the actual syntax. We have our return type for main. The method name is main. Opening parenthesis. Then we have our comma delimited list of parameters. In this case, we have one parameter that this guy takes. Closing parenthesis. Make sense? Okay. So, and I'll talk about this in a second, but let's get our program working. So there's our hello world program. So we come up here, hit the little play button, and we see hello world output. Okay? Now, let's talk about the main method here. What I'm going to do is I'm going to come out here to a terminal. Because clearly we don't need to be using Eclipse. It's too easy of a tool, right? Did we do this last time?
Yes.
Okay. So, did I already have a program out here that I used?
You did a hello world again.
Okay. But we didn't look at command line arguments, did we?
I guess not. If
Okay.
I can't remember.
Oh, here, we'll call it hello.java. So for starters, Eclipse does this for you, but your class name must be the same as your file name. So I named this file hello.java with a capital H. Class name must be the same. All right, so there's my hello world program. I'll compile it. Then I'll run it. So those are the steps that Eclipse does for you. Okay? But now, we go back in here, and we look at the parameters that come through main. Its name is args. We can name it whatever we want. We can call this elephant if we want. No big deal. Still works fine. But the reason it's typically called args is for command line arguments. Historically, our programs may have taken parameters when you ran them. So, for example, just so I don't have to show you too much, I'm going to print out the first two arguments that get sent. So I better send at least two arguments to this guy. So I'm going to compile this. Every time you make a change, you have to recompile it. Now I'm going to run it, but I'm going to pass it apple and orange. And we see that apple and orange get printed out. So that variable, whatever, it's a string array, but we haven't learned about arrays yet. That variable takes in our command line arguments and allows us to use them within the program. Now, you might say, why do we need something like that? To that, I answer with that, or with that, or with that. Each of these three things is a program. This is VI. It's a program named VI. VI requires an input in order to open it. What does it need? It needs the name of the file I want to edit. Here's the Java runtime environment. It requires the name of the program you want to run. Here's the compiler. It requires the name of the file you want to compile. These are examples of real programs that we're really using that require command line arguments. It just so happens that modern day computer users rarely see stuff like this because they're all hidden behind icons and buttons. You know, if we're inside Eclipse, we just hit the play button. And magically it calls Java, in this case it would be hello, I guess, and just runs it for us, right? Okay, so that's what these guys are for. Command line arguments. Realistically, you will rarely use them. But that's why they're there. It's a historical thing. Remember, Java came from C++, which came from C. And everything we're looking at out here, the command line, was more than likely written in C. Okay? All right, so questions about any of that? Got a pretty good idea how to use Eclipse, and everybody got a Hello World program working on their machines, all that crap? All right. So now let's start talking about stuff. Variables. So last time, beginning of class, we talked about the three ways human beings solve problems, right? Memory, asking questions, and repetition. And we said that the way that computers mimic the way that the job of a programming language is to mimic the way that human beings solve problems, which means that we need to come up with a way of mimicking memory, mimicking asking questions, and mimicking repetition, right? Now, just as a quick reminder for myself, okay, I just want to know what I had talked about, what I didn't. Good. What's up?
Said you went through that quick.
Not my first rodeo.
Sure.
I just didn't want to repeat myself. Because we only have 4 hours.
I know.
Man, this class should really be 8 hours a week, shouldn't it?
Huh?
No homework.
Yeah, no homework, but 8 hours. I'll take that.
I wouldn't.
Well, no, because you won't.
How about no homework in 2 hours? We wouldn't cover enough material. What was I talking about? Oh, variables. Okay, a variable is a named container for holding a value. Variable is a named container for holding a value. Remember, these guys are the guys that help us simulate memory, simulate remembering stuff. Why do we need variables? When we need to use a value more than once. Just like in real life. We only remember things that we need to bring back later on, right? Okay, generalistic syntax for variables is type name equals value, semicolon. And the equals value part is technically Well, that part is technically optional at the time you create the variable. So this is the generalistic syntax for defining a variable. You could also say type name. Both of those will define a variable named name. But you do want to put a value in a variable before you start using a variable. So you're not required to give it a value at the time you create it, but you are required, well, you're actually not required to ever put a value in it, but I would highly encourage you to put a value inside of a variable before you start solving problems using your variables. Otherwise, you're working with magical randomness that might have gotten put into the variable on its own. Okay. So, what's a type? Types describe the kind of values that a variable can hold or is built to hold. So just like if you go out to Walmart or Target or whatever and you buy some stuff, you can buy containers there, right? And certain containers can hold all sorts of different things. Other containers can only hold certain kinds of things. For instance, if you were to buy a laundry bag or a laundry basket, hamper, you know what I'm talking about? Okay. Would you want to fill that with water? Why?
Because it has holes.
Has holes in it. Why does it have holes in it? Is it so
To let
like the
funk
mildew,
out. Let
the
it
funk, let the
yeah.
funk out?
Mhm.
Shouldn't they be trying to keep the funk in?
Well, the more you air it out, the easier it is to clean. I would imagine.
Less plastic.
That's what?
Less plastic because it doesn't need like more.
Oh,
Oh, that's the smart answer.
efficient. Where are you from?
India.
India. Efficiency.
Mm-hmm.
Less plastic.
I'm thinking about the smell.
Okay, but the point is that you would not want to put water in those because it won't hold water, right? So you are limited to what you can put into a hamper. It doesn't have to be clothes. You could put, basketballs and crap like that in there, no problem. You could put anything in there that's not bigger than the holes that are in the hamper, and you'd be fine. But anyways, a type describes the kind of value that a variable was built to hold. Remember, this goes back to what we talked about last class, where there are two kinds of programming languages, strongly typed and loosely typed. Strongly typed languages are typically compiled languages where we must describe what kind of value a variable was built to hold at the time we define the variable. Loosely typed languages don't require us to define what kind of value the variable is built to hold. We can go to Target, buy a basket, put whatever we want in there, and it'll just work out. Hopefully. Okay, so, and typically what we want to think about is we want to think that strongly typed languages are typically faster languages. Loosely typed languages are typically slower languages. Okay? So, a type describes the kind of values that a variable can hold. So what are our types? Well, we have two kinds of types. We have primitive types, and we have object types. Primitive type variables are built into the language. I'm not spelling that right over and over again. There we go. They're built into the language and can only hold a value. That's the extent of what it knows how to do. Primitive type variables are built into the language. Primitive types are built into the language and can only hold a value.
So like a constant.
We'll talk about examples of them in a second here. Object types may or may not be built into the language. and can hold 0 or more values and potentially do more. So the short answer is primitive types are simple variables, object types are more powerful variables. And notice that object types may or may not be built into the language. So for instance, Java comes with a bunch of predefined object types, but we can also make our own object types. And we will do that. Okay, well, we're not going to talk about object types for a little bit, so let's start talking about primitive types. Examples of primitive types. We have byte, short, int, long, char, float, double, and Boolean. So those are our primitive types for Java. Do you want to see the primitive types for C#? If you'd like to see the primitive types for ObjectiveC, if you'd like to see the primitive types for C,
Noble.
we'll talk about that. We'll talk about why soon. Man, these languages are so different. All right. It actually gets somewhat entertaining during the week. So on a given day, I might program in maybe a minimum of 3 different languages. Teaching, while I'm teaching in class, live programming, and then if I'm doing my own stuff, it might be in even another language. So sometimes I just start mixing them together. Sometimes it makes me feel like a dumb VB programmer.
Excuse you.
I like
You might as well be programming in VB, making those kind of mistakes.
I can still program in VB. Cast stuffed ice cream cone. All right, so let's talk about each of these. Remember, primitive types. They are built into the language and are only capable of holding a value. That's it. No additional magic tricks. So every single one of these types only describe what kind of single value they can hold. Okay? So bytes hold signed whole numbers.
What do you mean by sign?
Signed positive and negative.
Oh, okay.
So that's for a byte. Shorts can hold signed whole numbers. Ints can hold signed whole numbers. Longs can hold signed whole numbers.
Letters.
Huh?
Signed letter. No, just one.
Signed whole numbers. Oh, this gets even funnier. I'm going to stop right now.
yeah.
You want me to show you a preview? Show you a preview. That's what I'm going to write there.
Thanks.
All right, so we have 4 different ways of holding positive, negative whole numbers. Why? Why do I need so many different ways of holding the same crap?
Depends. It's the same question. I mean, the same answer.
I thought, well, I know one of them. I don't know which one will allow, oh, never mind. You said whole numbers. I was going to say something with decimals.
Yeah, that gets down here. Yeah, all these guys. A byte, for instance, I can store the number 5 in a byte. I can store the number 5 in a short. I can store the number 5 in an int. I can store the number 5 in a long.
But some of them hold more memory.
Okay. So let's talk about these. What's a byte?
A bit.
What's a bit?
8 bits. 5, 8
A bit is a
1, 0.
0 or 1. A byte is 8 of those.
Yeah.
Right? So 2 to the 8th power is the maximum size of a unsigned byte. But this is a signed byte. So it's plus or minus 2 to the 7th power.
Why 7?
Because one of the bits, the 8th bit, is used to keep track of whether it's positive or negative.
Oh, gotcha.
Okay? So the range of values is negative 128 to positive 127. That's the range of values that can be stored inside of a byte. If it was unsigned, it would be 0 to 255. A short is a signed 16-bit. So 2 to the 15th. Negative 32,768 to positive 32,767. That's the range of values that fit inside of a short. An int is a signed 32-bit number. Negative 4 billion to positive 4 billion. And a long is 64-bit. Negative, big number, to positive, big number. So it's negative 2 to the 63rd power to positive 2 to the 63rd power. 63rd power.
Supposed to be 4 million minus 1.
Huh? Negative 4 billion to positive 4 billion.
Not minus 1. Because the
Well, you could, I mean, whatever. You could say these are rough numbers. I mean, I'm not giving you exact numbers there. These are exact numbers up here. Then my precision drops. I don't have that number memorized, and I really don't have this number memorized. If you want to see it. Let's see, 2 to the... Oh, actually, I lied anyways. It's negative 2 billion to positive 2 billion.
Stop writing a pen in your class.
Seriously. So there, it's that. It's negative this number to positive this number with a 7 there instead of an 8. That's for ints. For longs, it's that. So add 18 zeros onto the end of this, and we're home. So I think I did a pretty good job of estimating that it's a big number. Now, I guess one thing I throw in there, one caveat would be that it's not an infinite number. There may be situations where we need a bigger number than this.
Wouldn't you just use a string for that?
Well, yeah, but then you have to use an object that allows you to work with arbitrary integers. But for right now, we're not going to use numbers that big. So we're fine. Make sense? Okay. So now I go back to my original question. Why do I need 4 different ways of storing numbers?
To save memory.
Well, why do I care about memory?
Because it'll hold the spaces, number of spaces, even if you don't use them all.
Okay, well, let's look at a long.
So division.
Hold on. So a long takes up 2 to the 64
62.
bits.
Right?
Plus or minus 2 to the 63rd. but the footprint for it is 2 to the 64 bits. So that's the number of bits that go into a long. So let's divide that by 8. Now we're at bytes. Let's divide that by 1024. Now we're at kilobytes. Let's divide that by 1024. Now we're at megabytes. Actually, hold on. I screwed this up. I really screwed this up. A 64-bit number. I don't need, not 2 to the 64th. A 64-bit number is actually an 8-byte number. An 8-byte number is actually a 0.0078 kilobyte number, or a 0.000076 megabyte number, or a gigantically small gigabyte number. How many gigabytes of RAM do you have in your laptop? RAM. Probably 4? 4 gigabytes? Okay. So we have this number. 4 divided by that. We can store, what is this? 536,870,955
Bytes.
longs.
Oh.
536.8 million longs we can store in your machine's RAM. That's a lot of longs. Do we really care? How many of you wouldn't just use longs all the time? Are you really going to use 536.8 million of them? Even if we used half that. But he said that we need all these different ways of storing these numbers to save memory. How many of you recently upgraded RAM in your computer? Last couple of years or something like that? Put new memory in your computer. How much? What did you upgrade it to? From what to what?
I upgraded it from 2 to 4.
2 to 4, okay? And so did you buy an extra 2 gigabytes, or did you replace the 2 gigabytes that were there with 4 gigabytes of new memory?
I replaced them.
Okay. What did you spend?
I don't remember.
Ish.
I bought it on Newegg.
So you bought 4 gigabytes of RAM, right? Okay. Probably spent something like $80. Would be my guess. Okay. Let's roll back the clock to 1997. I had a computer that came with 8 megabytes of RAM. It was bleeding edge. We had to wait for it to release the chip from Intel.
Flash memory now.
Huh?
It's the same size. Flash
8?
memory.
No.
No.
8 megabytes.
Megabyte.
Megabytes.
So small.
So I had 8 megabytes. He has 4 gigabytes. So in 1997, I had 512. No, actually, it should be more than that.
Yeah.
I went the wrong direction. No, that's right. I had 500. So 8 times 512 gives me that. Oh, right. So he has 512 times more memory than I had in 1997 in a bleeding edge computer. And he's running around with an ultra portable laptop with only 4 gigabytes of RAM in it. Anybody have a laptop in here with more than 4 gigabytes of RAM? Not surprising. Anymore, you can get a lot of the newer bigger machines that come with at least 8. You can get 16 in some of them.
I think I have.
Okay, but regardless, in 1997, my computer had 8 megabytes of RAM, and I decided, let's upgrade this to 16 megabytes of RAM. So I bought an extra 8 megabytes of RAM. Now remember, since 1997, there's been quite a bit of inflation, right? So, $50 in 1997 is actually a lot more money today. Probably $80 today buys you the same thing that $50 bought you back then. Maybe even more than that. It probably is more than that. Okay, so I upgraded from 8 megabytes to 16 megabytes. How much do you think I paid for an 8 megabyte RAM chip? Keep in mind, she just got 4 gigabytes of RAM. 4 gigabytes of RAM for like $80. How much do you think I paid in 1997 for 8 megabytes of RAM?
$180.
How much?
180.
180, okay? This is like the Price is Right. 300,
500.
500,
200.
200, $1,000.
Holy man.
$1,000 for 8 megabytes of RAM. That might be like $1,500 or $1,600 in today's money for 8 megabytes of RAM. What's the punchline? Memory used to be significantly more scarce than it is today. Java is a language that's based off of C++, which is based off of a language called C. Well, these languages were born in the time when memory was a lot scarcer, was a lot more expensive. It was not a good idea to just always use longs. Why? You don't have that much space. If I only have 8 megabytes of total system RAM, I can't fit anywhere near as many longs. And keep in mind that in 1997, 8 megabytes of RAM was considered ridiculously awesome. Famous guy, Bill Gates. Any of you heard of him?
Mm-hmm.
Microsoft guy, right?
Yeah.
He is. Anybody know his famous quote related to RAM?
No.
He said, "You will never need more than how much RAM?" Another Price is Right question. Bill Gates said, "You will never need more than blank RAM."
16 gigabytes.
16 gigabytes?
25 gigabytes. I don't know.
2.5.
2.5 gigabytes?
250
250 megabytes. You will never need more than 32 kilobytes of RAM. 32 kilobytes of RAM.
When did he say that?
Back when 32 kilobytes of RAM was a lot of RAM.
Mm-hmm.
That's when he said it. Here, since we're on the topic of this stuff, let me kick over to a slide. I want to make sure everybody's on the same page. Bits, bytes, etc. Okay, so we have something called a bit, right? A bit is a 0 or a 1. Then we have something called a kilobit. What's a kilobit?
1024.
How many of you have ever worked at a Best Buy?
1,000 bits.
You think it's 1,000 bits? That's the answer I was looking for.
1012.
That's not even close to the answer I'm looking for.
Sound
I was looking for the right answer. And then the answer everybody else gets. Okay,
1024 bytes.
1024. So a kilobit is 1024 bits. Not 1,000 bits. If you go through Best Buy's training program, they tell you that it's 1,000 bits is a kilobit, or 1,000 kilobits is a bit, and then all of a sudden you're just speaking in these guys. They're idiots.
That's why Geek Squad sucks.
Well, no, Geek Squad sucks is because that's the best of the idiots. How many of you have ever paid Geek Squad to put memory into your computer?
I paid them for other things.
Did you have them put memory in your machine when you upgraded it?
No, that's when I bought a Dell and they supposedly did it, but my internal fan and the rest of the computer kept breaking.
Because what does Best Buy charge to put RAM in a computer?
$50.
50? How many of you have ever installed memory in a computer? How long does it take?
5 minutes.
1 minute
Yes.
tops. Right? It even makes a little clicky noise when you. I mean, it's like putting bread into a toaster.
The time you
It
spend
really is.
just
You
to
slide
find
in
the
there
screw
and
time.
it goes click.
A lot of these machines don't even have screwdrivers anymore. You just have like a little lever, and then the side's off. You hold the RAM chip, and there's only one place in it that obviously can go, and you can put it in backwards; it won't go in. Don't just keep pushing. If it doesn't seem like it's going in easily, you're doing it wrong. And eventually, you see the two little hooks on the side go. Done. $50. It's like 5 pizzas.
Dude, you telling me.
What's up?
I said, you telling me. That's good money for pizza.
Seriously. You go to one of my developers says Aldi has like the best frozen pizzas.
They have Jack's Pizza, dude.
Is that what I don't go in Aldi. I'm afraid of getting mugged.
Not all of them are in the hood.
Actually, there's an Aldi right. I live up in Grafton, right by Costco,
Oh, okay.
and there's an Aldi there. It doesn't make any sense to me, because I thought they were all in the hood. So, why is it up there by Best Buy? See, like I said, they're all in the hood. Yeah, but apparently, they had. They have. I don't think it's Jack's Pizza. He mentioned something else, but I guess they're $1, and I guess they're like really good. So he buys them by like the caseload.
That is obsession.
And here, the funny thing is, it's the guy who's texting me right now. Creepy. All right. So, anyways, a kilobit is 1,024 bits. A megabit is 1,024 kilobits. A gigabit is 1,024 megabits. And I've never actually heard this term, but a terabit would be 1,024 gigabits. Now notice that on all of those we talked about bits. A byte. This is 8 bits. A kilobyte, capital B, is 1,024 bytes. A megabyte, capital B, is 1,024 kilobytes. You could also do capital KB.
Oh, okay.
That's legit. In fact, that's how it's usually written.
Yeah, don't
like that.
scare me like that.
A gigabyte is 1,024 megabytes. A terabyte is 1,024 gigabytes. Anybody knows what comes after? Does anybody know what comes after a terabyte?
Wasn't it like that?
Petabyte.
A who?
Petabyte.
Petabyte? What comes after a petabyte? Exabyte.
Excellent.
What are you looking on Wikipedia?
Yes.
Yeah, on check.
Yahoo.
I had wings for dinner, and I don't think I washed my hands that great. I just rubbed Thai chili sauce into my eyes. Well, they were so good.
And you didn't bring any?
There, you have to eat them there, half price.
Well,
Fire Ridge Golf Course up in Grafton. It's a restaurant called Flannery's. Really good wings.
So that's where you left too.
Well, I finished teaching at 3, then I had a meeting. So at 4:30 I had wings until whatever I had to come back here and do this crap.
I saw you leave. I'm like, where in the world is he going?
She's stalking me.
No, I didn't. I was sitting in the library. That
Oh.
big old window.
That's what students always say. I was studying in the library.
I was. My paper is
We have a library here?
Yes.
Oh, that's the place with the coffee shop. Right? They got the
Yes.
coffee shop and library.
Yeah, they do.
That's right.
Which makes no sense that they don't have a bathroom inside the library. You have to like wander across a life.
Well, this place used to be a what do they call nunnery?
But still, you need a bathroom everywhere.
Why? They're nuns. They'll hold it. Ay. My poor wife, right?
Yes.
You
don't have any children, do you?
Oh, I hate kids.
Oh, okay. Good job for.
I have 3 cats.
Why do you have cats?
Love my cats.
Cats are like the devil reincarnated.
One of my cats is totally. 2 of my cats are 25% lynx. We got them from an animal rescue place in Arkansas. The big lynx, she's my kitty. Her name's Gracie. She is like an emissary of hate. She is so mean. But that cat worships the ground I walk on. She bites everybody. My wife can hold Gracie about 85% of the time. The other 15% of the time, Gracie just rips chunks out of her arm.
Holy man.
That cat would never bite me. It's like a total baby doll with me. And she's huge.
They're demonic.
She is.
All cats.
She's vampiric, actually, and Jewish.
I didn't know.
She eats off of a Passover plate.
I didn't know animals can be.
We also, for Hanukkah last year, got her a Jew mouse. It's a little mouse with a Star of David on it.
Mm-hmm.
So
Interesting.
you think I don't hold up jokes? You
No,
think I just keep jokes going in class?
No, I think you.
During break, I'll show you pictures of my cat with her Jew mouse. No, once I lock onto a story, I stick with it. All right, so this is your bits bytes conversion table crap. Okay, so just real quick to kind of put this into kind of a common thing that people find interesting along the lines of this stuff. How many of you have internet at home? What speed internet do you have? If you're an IT major, you don't know what your speed of your internet is. I just dropped you from the program.
No.
7 Mbps.
You have 7 megabit per second? Oh my
Yes.
God.
15.
What, are you stealing from your neighbor?
No.
You're paying for that? Was that
That's
4?
the actual rate.
Well, that's a number, yeah. Were you paying $4 a month?
3.
7 Mbps. Like,
7 megabit per second, right. That's like budget pleaser internet.
That isn't even budget.
Are you AT&T?
That's homeless.
Are you cable?
Time Warner.
So you're on Time Warner's budget cable modem.
No, like that's the fastest one. Like 7 Mbps. When I run the video.
No.
This is not.
No.
Oh, hold on. You're probably misrepresenting the number then to me. You think this is their fastest one?
Yeah.
Okay. It's probably that. 50 megabit bit.
Megabit.
You think you download around 7 megabytes a second?
Yeah.
Capital B?
Yeah.
Okay. This is what I have at home too. I have 50 megabit at home.
I think he's just nodding in.
Well, hold on. This is the point of why I'm talking about this slide. Okay? What other internet connections do we have at home?
15.
15 megabit per second?
I think I agree with Bender, but let me double check.
What else we got?
15.
15? Now 15, is that still Time Warner?
Yeah, Time Warner.
Time Warner.
Anybody have DSL? Through AT&T or phone company?
Played out.
I'm AT&T, but U-verse not.
Yeah, what's your internet connection?
12.
12?
Yeah.
Okay, that's DSL. So you're 12 megabit per second, DSL. This is about as high as you're going to see DSL go. 12 megabit per second.
How come they have like an 18?
You have to really check to see where you can get it. DSL it historically has something called the final mile. Anymore, it's now it's like the final 10 miles. Everything's relative to how far away from the home office you are. In order to get an 18, you need to basically be in the backyard of the phone company. So 12 is pretty good for DSL. Okay, so we're going to call these common internet speeds. Okay, so now when we download stuff off the internet, we see this all the time. 50 megabit per second, 15 megabit per second, 12 megabit per second. What the heck is a megabit in terms of what we recognize as download speeds? When you download something off the internet, we're usually measuring it in what, kilobytes per second? How fast, how many K per second something is downloading? Maybe.
That's not
On the high end now, we're downloading, we might look at megabytes, but usually we're looking at kilobytes. So if you're downloading a 100 megabyte file, like Eclipse, when you downloaded Eclipse was like 250 megabytes. Okay, you were probably downloading it at, with some of these internet speeds, maybe 200 or 300 kilobytes a second, right? Something like that. It was probably about the speed you were getting it, 200 or 300 kilobytes per second. So the question is how fast are each of these capable of in terms of kilobytes per second? 50 megabit per second. That's 50 megabit times 1024 gets its kilobit times 1024 gets its bit divided by 8 gets its bytes divided by 1024 gets its kilobytes. So a 50 megabit per second internet connection is capable of downloading at 6,400 kilobytes per second. Whereas most of our internet connections probably grabbed Eclipse at around 300 or 400 kilobytes a second. Even yours, that could pull at 6,400 kilobytes a second. Because you can only download as fast as they're willing to give it to you. Okay? So if you want to take this to megabytes, then we will divide it by 1024, and we get 6.25 megabytes per second is the theoretical maximum download speed of a 50 megabit per second internet connection.
So
6.25 megabytes per second is the theoretical maximum speed of a 50 megabit per second internet connection. Make sense? Similarly, if we go ahead.
So does that make it good or?
Well, 6.25 megabytes per second is pretty good.
Oh, okay.
Yeah, this is fast internet.
So it takes
But I'm just saying that when people see 50 megabit per second, it doesn't mean anything to them.
True.
Okay? Because he could have seen 6.25 megabit per second, and he would have compared it to 50 megabit per second and thought this one was faster.
So it takes 40 seconds to download the Eclipse with the speed.
At the maximum speed, yeah.
40 seconds.
Here.
I divided it to 150 with 6.25.
Yeah.
40 seconds.
But that's if they can give it to you at 6.25 megabytes per second. I mean, most of the time your download on a 50 megabit per second connection, you're only going to max out your connection if you're downloading from places like Apple or Microsoft. Other places, you're going to be pulling a portion of your bandwidth. So you have plenty of extra bandwidth to use for other things. So the point is that if you walked into a store, here, let's do it this way. And somebody said, well, you can get one of these two internet connections. Most of us would have chosen what?
The 15.
15, right? It's like, oh, probably this is just a typo or something. What does that mean? Same crap, right? When this is many times faster than this one. 15 megabit per second is 1.875 megabytes per second. Twelve is 1.5 megabytes per second.
But the provider, like, they are specifying 7 is the max instead of like 6.25.
Well, they're lying. Assuming this is your number. If they're saying it's 7 megabytes per second is the max, I mean, first of all, understand that somebody selling 7 megabit per second internet, that exists. 7 megabit per second still exists. My office has 7 megabit per second.
Is it dial-up?
Huh? No, that's way faster than dial-up.
I mean,
Way.
I'm just,
Here, we'll ask a
Okay.
question. Ready for the next question to embarrass our people?
thank you.
Do you want this or do you want a T1 line?
I don't know what the T1
Have you heard of a T1 line? You've never heard a T1 line referenced in movies or anything? Are you serious?
Yes. So who's embarrassed now? No.
All of you should be if you're technology majors. Seriously, raise your hand if you have never heard of a T1 line. How many of you are lying? See, T1 lines, they're dedicated circuits run by the phone company between 2 points. You know, so historically, a T1 connection was considered to be ridiculous. So fast. Like, T1 connections cost many thousands of dollars per month for a T1 connection. $10,000, $12,000 a month for a T1 connection, even today. So would you rather have 50 megabit per second internet through Time Warner, or would you rather have a T1 line? One might guess T1 line sounds better, right? And if you guys knew what you're supposed to know, how could you not hear of a T? Hold on, how many of you have had the networking class?
This one.
Who'd you take it with?
D.
With the beach.
Who?
Beach.
Greg, Gary,
Greg.
Greg,
Beach.
D.
Okay,
That's
so
it.
you took the networking class and you don't know what a T1 line is.
We hadn't talked about
Are you in it now?
last semester.
I
Why,
just
did
threw
you
open my
both
mouth twice.
Thanks for the extra information.
Oh my God.
Well, why don't you
There
teach
could
networking?
be-
I don't want to teach a stupid networking class. I got
Well-
better things to do. I'm teaching it to you now, apparently. So, anyways, historically, T1 lines, people, in the early days of the internet, people would refer to T1 lines as basically infinite speed internet. Because T1 just seems so ridiculously fast. Because this was back in the days when you had 56K modems, 56 kilobit per second modems. So like roughly 4.8 kilobytes per second download speeds. A T1 line is 1.44 megabit per second. 1.544? That? Megabyte per second. Megabit per second. So, roughly a megabyte per second download speed. Roughly. So a 50 megabit per second download is way faster. Something like 30 times faster than a T1 line. Now, the one thing to keep in mind about your home internet stuff is that your 50 megabit per second connection is 50 megabit down, 5 megabit per second up. Something like that. They're called asynchronous. The upload speed is slower than the download speed, so you can't run servers out of your bedroom.
Kind of like
Oh.
10%.
So now if you're paying, do you know how much you're paying per month for your internet?
55.
55 from Time Warner?
Yeah.
Okay. You have 50 megabits. You have this. That's what you have. At 55 for consumer internet, you don't. If you have that and you're paying 55, somebody should be sued. You're in a TV package, right?
Yeah.
So you have television plus internet. Yeah. This is what you have. You have that.
And as for the fastest.
Yep, that's what you have. You have their fastest.
Hold up.
But if they're saying it's 7, they're lying. The theoretical maximum is 6.25 megabytes per second.
They have an application like with which when they run it, it shows like a meter.
Yep.
It stops like somewhere about like 6.8 or something like that.
Well, then they're not selling you a 50 megabit per second circuit. They might be selling you something higher than that. They might say they're guaranteeing it at 50 or something, but maybe their circuit actually goes faster.
Maybe their application is like incorrect, not showing like
I think Roadrunner uses their own thing just to test theoretical speed. So you're talking to their own server. Because there's no way for you to test it. Like if you go to speedtest.net or something like that, I mean, you're at the mercy of where you're downloading from and stuff like that. So they're doing a test to see what your theoretical connection is to their own equipment. I mean, if it is a 50 megabit per second circuit, which is what they're saying it is, it should not be able to possibly go faster than that. So if it is going faster than that, that's fine. That must be that they're really selling you something like a 53 megabit per second circuit or something like that. You know, they're erring on the high side, which is not necessarily surprising because I think soon they're coming out with 100 megabit ultra wideband. So imagine 12.5 megabytes per second. Sick. All right, but anyways, the punchline here is that you see how all these numbers relate to each other. You know, we're looking at it from the perspective of our internet connection speeds, which we can all relate to, right? But back here, we're seeing how those conversions actually happen. And here, we're seeing that those exact numbers are used when we talk about storing stuff. Okay? So something Dr. Locklear would say all the time is that these are the grand ideas of computer science. Okay? All this stuff connects to other stuff. Okay? I don't agree with most of the stuff he says, but that's one of the things that actually makes sense.
Oh, man.
I'm like way bigger than he is.
I hope he does never listen to your lectures.
Gary sees me every single day. He stands there sometimes when I make fun of him. He makes fun of me too, who works out.
I've never heard him make fun of you. Actually, he spoke very highly
Well,
of
who
you. when
wouldn't?
I can think of several people. No, I'm just playing.
No, we have a very strange department here.
Oh, that's funny.
Yeah, no, like in a good way.
Yeah, it's good.
If you take all of our faculty members and you average us all together, you actually come out with like a normal human being.
Oh,
Because I'm nowhere close to normal.
no.
Gary's nowhere close to normal. Now, Professor Wall, he's kind of normalish.
Yeah, he kind of averages everybody.
Yeah.
What about you?
Oh, I'm not normal. Have you seen the way I dress?
That's a key. Right. My first time seeing you, you were walking down the hall, and I was like, who in the blanket? And I was like, oh, that's my professor.
I know, it's so good.
You saw him once you were in the library?
Yeah, just stalking me. She's in the library. She's
No,
hiding in my garage. All right, hold on. Let's finish the slides so we can take a break.
I'm not stalking anyone. I'm just saying.
Just don't mark up my face. Okay, so why do we have all these different ways of storing integers? We have all these different ways of storing integers because back when these primitive types were invented in the older language C, memory was at a premium. And if you were going to store a number that was less than 127 and greater than negative 128, put it in a byte. You don't want to have any bigger, you don't want to have a bigger memory footprint than you need. Okay? Now, the punchline with some of the stuff, we'll kind of finish up before I break with this, is how many of you have heard of the Y2K bug?
Yeah.
So you've heard of that, not the T1 line?
Right.
You know, that T1 line thing, they still reference in some of these stupid shows you watch.
Sorry.
And you're
I
supposed to
don't
get
catch
it.
I don't catch it. Now I will. Thank you for your great wisdom.
But they reference it, like, they reference it dumbly. They reference it dumbly. More bestest. Because they still talk about it like it's a ridiculously fast connection. Because they just think most people don't know.
Maybe they'll mention it in like the Big Bang Theory one day. And
No, Big Bang Theory is smarter than that.
Oh, okay.
They make errors as it relates to like video games like World of Warcraft and stuff.
True. And
You know.
science.
Yeah. So that's where they make their errors. Bad researchers. Okay, so Y2K bug. What was that?
The world was gonna end.
The world was going to end, obviously, sure. So what was the Y2K bug? We had a bunch of software, right? Bunch of software written before the year 2000.
Yeah.
And a lot of that software used 2-digit years for this very reason. Well, chances are we're not going to have this software forever, so let's use 2-digit years because it takes up less memory. Well, what's the difference between 1900 and 2000 if you're using a 2-digit year? Nothing. So think of all the programs that could break just doing calendar math. How many days ago was this? It was actually 13 years and 2 months in the future. Because things would overlap, right? So, I mean, it was a problem. So they had to go back and rewrite all this software to recode the dates to be 4-digit dates. And the funny thing was, it wasn't necessarily hard programming. It was tedious programming. Every single place inside of a piece of software where somebody years and years ago was making the smart decision to preserve memory by using 2-digit years, they had to go and make a new smart decision to allow us to get to the year 2000. And for the computer system not to think it was 1900. Punchline being, we don't need to worry about it today. When you write your programs today, you're not going to care whether you're working with a int, a long, a short, a byte. We have so much memory, we don't know what to do with it. And adding more memory is cheap. You know, even if you're paying top dollar to Apple, if you go into Apple's website right now and you configure one of their brand new Mac Pros, and you want to bump that guy to 16 gigabytes of RAM, it's like an extra $200. That's Apple price. 8 gigabytes to 16 gigabytes, I think is $200. Somebody else probably would, if it wasn't Apple, somebody else probably would pay you to upgrade it. So, price of memory has come way, way down, and memory capacity has gone way, way up. So we don't really need to worry about this stuff anymore. So realistically, as a programmer, you will never use a short. You will almost always use ints. Sometimes you'll use longs when you need them. And every now and then you might use a byte, not because of the size of a byte, but because when you're streaming video or something like that, it's coming in 1 byte at a time. That just happens to be the chunk size that it's coming in at. That make sense? Okay. So let's take a break. What time is it?
7:45.
Okay, let's come back at 8. It's 15 minutes. Go pee or smoke or whatever. But be back right at 8 because I may give a quiz.
You never said anything about no quizzes now.
I
What's
just
going on?
did.